Question is, a straight wire carrying a current of 12 ampere is bent into a semicircular arc of radius 2 cm as shown in figure. Consider the magnetic field B at the center of the arc. A. What is the magnetic field due to the straight segments? B. In what way the contribution to B from the semicircular differs from that of a circular loop, and in what way does it resemble? C. Would your answer be different if the wire were bent into a semicircular arc of the same radius but in the opposite way as shown in figure? So you can see that for question number A, what is the magnetic field due to the straight segments? We know that for a point at O, dl, that's the current element, and the radius vector for each element of the straight segments AB and DE are parallel. So you can say that the cross product of dl cross r will be 0 since theta is equal to 0. So for a point at O, dl and r for each element of the straight segments AB and DE are parallel. So the cross product of dl cross r is equal to 0, or dlr sine theta is equal to 0. Here sine theta is 0 degree. That's why sine 0 is 0. That's why you get the cross product of dl cross r will be is equal to 0. So therefore we can calculate the magnetic field at O due to the straight segments AB and DE is magnetic field B will be is equal to summation of mu naught divided by 4 pi, okay, I dl cross r divided by r cube, which is equal to dl cross r is equal to 0. So the product of this definitely will be 0. Therefore, the magnetic field at O due to the current through the straight segments AB and DE, which is equal to 0. Question number B. In what way the contribution to magnetic field from the semicircle differs from that of a circular loop, and in what way does it resemble? So let us calculate the magnetic field due to semicircular loop and the circular loop separately. Then we will compare it. So therefore the magnetic field induction at O due to semicircular arc is B is equal to, we know that the magnetic field due to center of a circular loop is mu naught I divided by 2R. Since it is a semicircular arc, we are dividing this divided by 2. So what we get? Mu naught I divided by 4R. Substitute the values. 4 pi into 10 power of minus 7 into 12 divided by 4 into r is given, that is 2 centimeters. So convert into meter, 2 into 10 power of minus 2. When you substitute the values, you get the answer as 1.9 into 10 power of minus 4 Tesla. So here the direction of magnetic field B according to right hand rule is normal to the plane of paper and inward direction. Okay. Now we are going to calculate the magnetic field at the center of the circular loop of radius r carrying current I using the formula B is equal to mu naught I divided by 2R. So which is equal to mu naught I by 2R. So 4 pi into 10 power of minus 7 into 12 ampere divided by 2 into 2 centimeters. So 2 into 10 power of minus 2. So when you substitute the values, you get the answer as 3.8 into 10 power of minus 4 Tesla. So this is the magnetic field due to the center of the circular loop, that is 3.8 into 10 power of minus 4. So here you can see that B dash is double than that due to magnetic field B due to semicircular arc. So here the direction of magnetic field at the center of the circular arc is same as due to the semicircular arc if the current is same and in the same direction. So it can be clockwise or anti-clockwise direction. And the direction of magnetic field at the center of the circular arc is different from that due to the semicircular arc if the current in them is opposite directions. Question C. Would your answer be different if the wire were bent into a semicircular arc of the same radius but in the opposite way as shown in figure? See, when the wire is in the same form as shown in figure, so we calculated the magnetic field due to a semicircular arc, which is B is equal to 1.9 into 10 power of minus 4 Tesla. Okay, so the magnitude remains same, but the direction will be normal to the plane of paper and directed outwards.